Hello everyone, welcome back to this is going to be the second video for the C2M. So we are moving from customer information, remember that V model, to the device information from the left to the right for this video. So before we start, I received a few questions last time about customer information, and there's a new feature about customer model, and in general, people are asking, what is the purpose of the customer model? So if you think about a utility company, when a new customer comes in, the first thing would happen is it would capture these kind of sales data on an object. And I see in some of the implementation, we use opportunity object to capture all the sales data. However, most of these customer information, we talk about different roles of the customer. It could be a direct customer, could be a broker, etc. So this information will be captured on the opportunity. You can leave that on the sales data, and that will just be processed during the onboarding process and eventually go into the contract management. So we could do it in that way. But more and more, what I've seen is the utility is starting to do different type of sales. They are extending their business into the non-energy business. For example, like the let's say for boiler insurance, and they're looking at EV charge, EV installation for the customer. So in these cases, it is driving away from traditional just energy-based sales. And in that case, you do need the customer information to be stored centrally. So you can't really just leave that. Well, you can, but you kind of lose a lot of important information for a customer. Because imagine you have a customer base, which you can look at the customer and say, this customer already have the electricity with us. Why don't we look at whether he needs the EV charge, for example? Maybe if he can move on to a smart meter, maybe the cost will be lower for him. In these cases, the business can do a lot of cross-selling and upselling as well. So customer information becomes quite important in that sense. So today we are going to move on to the right hand. Remember, the right hand is the premise, service point, and we are going to start to talk about the device information. So we break it down to 5 sections. So we look at the service points overview, look at the device config, measuring component, and at the last, entity model, put them together. Okay, so the first one is the service point overview. We look at the V model again. As I was mentioning, we look at the right hand side of this V model, and we will be talking about device. So device is installed on a service point, and the service points are normally located on the premise. And the service point can be either metered or unmetered. So for meter service point, there can be only one device installed at a service point at one time. Okay, so during the time, well, as time passed through, you could uninstall a meter, install a new meter, but at one point, each service point can have only one active device installed. Now let's look at the device. Okay, so let's look at the device. So first of all, before C2M, uh, both CCMB and the MDM, they have an object for meter. So in CCMB it's called meter, in MDM it's called meter. It's called device object. Um, once, well, actually before C2M, it is decided the MDM device will be used as the master object, because the concept for MDM, which stands for meter data management, is to master the metering side of the utility model. So in that case, the meter read, meter, and meter installation would all sit within MDM. Of course, now we have just one system, but remember, when we talk about meter, we're talking about MDM meter, which is device. Okay, second is device cardinality. So if you look at, well, as we mentioned, so a device can only have can be only installed on single service point at one time, but a device can have one or more device config over time. So in technical term, actually, when we say device is installed on service point, it is the link between service point and the device config. So that means it's just at one time you can only have one device config with one service point for that particular device. And then the measuring components, they are actually associated to the device, but also via device config. So device config become the link object between service point, device, and measuring component. Typical meter types. So when we talk about the meters, we can think about a few meters. I mean, probably 10 years ago when I started this using CCMB, majority of the meter is manual meter, because there is no concept of smart meter. There is some concept of AMR meters, where the AMR meters send the meter reads through the messaging, and smart meter becomes more and more popular. There's a smart meter rollout in Europe a few years ago, and it's actually bring. It's still, I think there's large percent of manual meter in the ground, because for domestic there's just so many there's so many old meters which cannot be replaced in time. But you can see the beneficial of smart meter is it's not only sending the meter read remotely, but also it can support remote commands. So it can be upgraded in terms of the firmware. It can perform additional functions, so you can talk to your meter just remotely. And so also for AMR and smart meters, you will see a concept called device event. They can send the status back to the utility or asset management company to tell what is happening with the meter at real time. So it is becoming more and more popular. Okay, then we talk about a few things related to device. So first of all, device identifier. You can identify device in many different ways. You can have different unique identifier, but normally you will have a serial number where um, the number is given by the factory who produced the device. Or you have a batch number, which is a number given by the supplier, normally who owns the meter. And last, you could have external IDs. If the meter has been imported from another system, you can have these information stored as the identifier, and that can be kept in C2M. And we talk about the smart and AMR head ends. Head ends actually just means when the meter reads is loaded into the system, and when the commands feedback is coming in. I mean, especially the communication coming from the meter into the grid, into the supplier. We can use C2M functionality for service provider and processing method to define the behavior. And also about device feature, we have a characteristic table as we have for many other objects as well. So that can be used to store additional information like asset certification, communication masters, etc. And the last is a meter service point. So if the service point is a meter, it doesn't mean we are not going to leave that with no measurement. We still have measurements, and probably they are either estimated or they are feeded from another system when it comes to billing time. We use standalone measuring components in this case instead of the physical measuring components linked to a device. And also we can use item object for the badged or unbadged assets where they don't really measure the consumption or usage, but they do need to be tracked as assets in the system. So for example, it could be a lamppost installed by the utility company. Okay, so device communication, as we mentioned, for smart and AMR meters. So for the commands to the meter, we can use the activity and the command object to track device communication for smart meters. There was a component called SOM, Service Order Management. I'm not quite sure if it's still. I think it is probably now a part of the C2M. So this part of the communication is built to allow the real-time communication between the device and the utility and track things in real time, and then store and to actually allow the system to react in a way if there is any urgent events happening in the field. And also we can use device event, which is normally another way of tracking events, but device event is more around not a outbound communication, but it's more around what the meter actually is feeding in. For example, the meter has a low battery, and then we can capture the device event. A device event could be a paired device event as well. So in some of the cases, we could have, let's say, the connection is lost as the first event, and then the second event is the connection is now returned, because there will be cases where these things happening, maybe because of network, maybe because of the meter itself. So to track those, we can actually uh, make sure we know what is happening during the time, especially when the meter read come in looks a bit strange or look a bit different from the normal meter reads. And also we can understand whether it is the meter issue or it's a network connection issue in those cases. So part 3, we'll look at device configuration. Now, device configuration, as I mentioned, it is connection object between device, measuring component, and service point. And it is representing a specific configuration of a device as a certain time. Over time, a device can have many device config. Device config can they are effective dated, and they are able to measure the quantity for the device over time. Each of the device config can have one or more measuring components, which is quite often in the INC world, because in INC, a lot of meter they have multiple register, not just for the energy but also maximum demand, etc., for half hourly meters. But also we have to consider, let's think about the half hourly meter. They could have multi channels, so they have day night, they have you have heard that like a 5 stalled, 7 stalled. They have multiple register to measuring at different state of the time, and in that case, it allows the billing and calculation of the consumption to be more accurate. Last attributes used to define device config include the device config type, parent device, the effective date, and also the time zone it's operating in. Okay, part 4 is measuring components. So measuring components, we can look at that, and then we can think about it as a register. So as we said, each device config can have multiple registers based on the time of use. So measuring components, they are the points where meter read is received and stored. Yeah, so when the meter read is stored against the register, and that's the measuring component. Measuring component can be either physical, linked to a device if it's a meter service point, or it can be standalone for a meter service point. Combination of unit of measure, time of use, and service quantity identifier actually defines what a measuring component measures. So that is very true, because if you look at each of the measuring component type, so these are the three attributes defining what the measurement means when it comes to consumption calculation. We will talk a bit more around this area, especially how billing is looking at these data. Okay. Last one, based on meter reads, measuring component can be divided into scalar interval types. So it could be for NHH, it's a scalar for interval for half hourly, it's interval, and also subtractive and consumptive. So in most of the cases for non-half hourly, if we get a meter reading, it is a scalar and subtractive, which means if I want to calculate the consumption, I will use the current reading minus the last reading. So that's scalar subtractive. For half hourly, normally what we receive is a half hourly consumption, so what has been spent in the half hourly in the last half hour. So that will be an interval type and consumptive type. So that is the concept around measuring component. And to talk about the measuring component, even to extend onto measurement, I want to bring in a very important concept called the VE rules. So VE rules actually stands for validation, estimate, and edit. So it is the set of rules which you can configure against the measuring component type, or you can configure that against the individual measuring components, which is override. So these rules will be run based on the measurement type. Either it's a menu, initial load, or estimate. So you can define different rules to be run at different points. And especially for estimation rules, it will be different from the validation rules, obviously. So in these cases, we will talk a bit more in the measurement chapter in the future, because there are many base rules. I believe is very important and is very helpful for many utilities, and we will expand more in the future. Okay, part 5, we look at the entity model together. As I have done that for the last time when we look at the V model, this time we look at the device related entities. So over here we have 4 of them: device config, measuring component, and device events. So you can see the device config is in the middle, and this is actually the object going to talk to, going to be linked to the service point, which we're gonna cover in the next part for the device installation. And we also have device, which stores identifier, characteristic, etc. Device event, we mentioned about that earlier. Measuring components, you will see a bit more characteristic, attributes tables, and also relationship tables. Some of the VE rules can look at, let's say, scalar measuring components, which is referenced by the interval. Then you can check between the interval and the scalar, so to make sure the communicative readings are actually matching the consumption recorded on the half hourly measuring components. Okay, that's everything. Thank you very much. And any questions, please raise it on the YouTube channel and see you next time.